NASA leadership changes again whilst budget discussions continue. The European Space Agency is betting on new rocket companies to launch its spacecraft. A new SpaceX crew mission is preparing for launch, and we have updates from Stoke, from Rocket Lab, from Relativity. You know what? Why don't we just cover everybody? There's a lot to come this week in Spaceflight. In a surprising move, this Wednesday, US President Donald Trump announced he had named Secretary of Transportation Sean Duffy as the new NASA interim administrator, effectively replacing Janet Petro, who was, until now, NASA's acting administrator. This latest move appears to be an attempt to install someone closer to Trump as an interim NASA administrator, rather than having Janet Petro, who is just a civil servant. Having previously been the director of NASA's Kennedy Space Center, Petro took that spot of acting NASA administrator on January 20th after the previous Biden-appointed administrator, Bill Nelson, had resigned. Without an administrator nominated, let alone confirmed by the US Senate, this was probably the next best option for the administration, to have a leader in NASA that's close to the president. Who was at one point nominated to be the NASA administrator, Jared Isaacman, agreed with this move, saying, quote, "Short of a new nominee, this was a great move. NASA needs political leadership from someone the president trusts and has confidence in." So, for now, until a NASA administrator is nominated and confirmed, Sean Duffy will take the reins of the agency, serving double duty. In response to getting the new job, the Secretary of Transportation posted on X that he was honoured to accept this mission and that, quote, "It's time to take over space. Let's launch." Perhaps the timing of this change isn't accidental given recent events. Last week, Congress passed the so-called Big Beautiful Bill, a reconciliation bill that gave NASA an additional $10 billion to spend in the next several years, something we covered in depth in the last episode. That money will eventually go on top of whatever is appropriated by Congress for NASA's budget. However, one main concern with this new administration are the proposed cuts to the agency's budget for fiscal year 2026, especially to NASA science. This week, all living former heads of science at NASA sent a letter to members of the House Appropriations Committee and the House Commerce, Justice and Science Subcommittee specifically regarding this issue. In the letter, they request Congress to maintain funding for NASA science and not approve the proposed cuts, citing that, quote, "To do otherwise would be to cede US leadership in space and science to China and other nations." The long appropriations process in Congress has already started this week, and it very much sounds like the cuts proposed by the administration may find challenges among senators and representatives.
For NASA, the bill reflects an ambitious approach to space exploration, prioritizing the agency's flagship program, Artemis, and rejecting premature terminations of systems like SLS and Orion before commercial replacements are ready. We make critical investments to accelerate our plans to land Americans on the lunar surface before the Chinese, but also in the technologies and capacity to land astronauts on Mars.
We rejected cuts that would have devastated NASA science by 47% and would have terminated 55 operating and planned missions. And instead, we provide $7.3 billion.
During this appropriations process, it's very common to see heads of different agencies and departments within the executive branch having to attend these hearings and defend the administration's position. Given that, it's probably best from the White House's point of view to install somebody as the head of NASA that can better defend the administration's position regarding the agency's budget than somebody that wasn't appointed by Trump himself. SpaceX and NASA are gearing up for the Crew 11 mission, the next crew rotation mission to the International Space Station. This Thursday, NSF's Sawyer Rosenstein got a chance to catch up with the crew on that flight prior to their trip to the Kennedy Space Center ahead of the launch.
Thanks, Ryan. This flight will see quite a few oddities. The commander of this mission was originally supposed to fly 2 flights ago. The pilot was supposed to fly on Starliner, and one crew member will double the current Japanese presence on board the ISS. Commander Zena Cardman was bumped from the Crew 9 launch along with fellow astronaut Stephanie Wilson to allow those 2 empty seats to be used by Butch Wilmore and Sonny Williams. They remained on the ISS after their Starliner capsule was deorbited without them due to safety concerns.
This is something that we train for, we're ready for as astronauts, and most important to me was ensuring safety of the mission.
She had already trained as the Crew 9 commander for 18 months, so does she have to retrain on everything for this flight?
For the Dragon training specifically, we did go through that entire training flow again. Even though that spacecraft is now very familiar to me, really felt it was important to go through that training with my crew. And it's not only about the technical side of things or learning the procedures or learning the systems, it's about how you work together as a team.
Pilot Mike Fink had to train for an entirely different vehicle. He was originally slated to fly on the Starliner 1 mission, but following the issues with the crew flight test, it was decided that he would shift to Dragon.
It was a change to go from all the terminology and the acronyms and the systems of one spacecraft and move over to another one pretty quickly. Fortunately, I had been working with the commercial crew program since like 2013, so I wasn't completely a noob to Dragon.
Mike previously spent Expeditions 9 and 18 aboard the station before spending 2 weeks on the orbiting laboratory on STS-134, the final flight of the Space Shuttle Endeavour.
My first mission, there were 2 people. Second mission, there were 3 of us at any one time. And now we're going to have a 7-person crew. So how to get along with so many brothers and sisters.
Now this flight will use Crew Dragon Endeavour. So does he now have a favorite Endeavour?
I'm very partial to Shuttle Endeavour, but we just got to see Dragon Endeavour last week. There's an ex-girlfriend and a new girlfriend, if you want to look at it that way, so we'll see how it is.
Japan Aerospace Exploration Agency astronaut Kamiya Yui will make his second trip to space after flying aboard the Russian Soyuz vehicle in 2015. He will join current station commander and fellow JAXA astronaut classmate Takuya Onishi.
He actually set hurdle very high for me. So I just want to work very hard to overcome, his ability. That way, ground team would impress me.
Yui hopes to show the world the unity happening aboard the ISS.
I just want to send a lot of positive message for the people, not only in Japan, but all over the world. ISS is a good example for the unite or cooperation.
NSF will have live launch coverage when Crew 11 takes to the skies from LC-39A in Florida, so stay tuned. Ryan, back to you.
Thanks, Sawyer. That Crew 11 launch is currently scheduled for no earlier than July 31st at 16:09 UTC, so make sure to keep an eye on our socials so you don't miss that coverage when it happens. This week was packed with news and updates from several US rocket companies, so let's dive into it. Relativity Space continues to make steady progress on the hardware and infrastructure for its forthcoming Terran R rocket. Work continues at the Cape, where water tower foundation work has been completed at Launch Complex 16. Key infrastructure is really taking shape as construction of the cryogenic systems continues into July. Relativity's Eon R engines are 3D printed using proprietary additive manufacturing, which simplifies the design, reduces the part count, and accelerates iterations during the development phase. The company has now finalized the design for the first stage engine, which means it can enter the production phase. Batches of key flight propulsion components, such as combustion chambers and injectors, are already beginning to roll off the line as the team starts to manufacture flight hardware. Meanwhile, the company reports it's now halfway through engine qualification tests, which simulate full duration burns for the ascent, re-entry, and landing profiles. A second stage vacuum-optimized version has also been shipped to NASA Stennis for testing. If for some ghastly reason you are a fan of stubby nozzles, the company is manufacturing a shortened version which will then be tested in the dual bay engine test stand at Stennis in place of the full-length nozzle extension. Almost 60 critical design reviews have been ticked off over the past quarter, ensuring each part will integrate smoothly with the rest of the system. These component-level reviews cover a variety of parts across the vehicle, from manifolds and avionics down to smaller details such as brackets. At Long Beach, welding is now complete on the second stage tank, and its downcomer, yes Jack, Relativity called it a downcomer, is also ready for structural acceptance testing. A new test stand is being built to perform that work, while outside, the structural test stand continues to grow. Shear towers have now been installed that will simulate the loads experienced during flight when testing begins on the stand later this year. Next, we move to Launch Complex 14 to the south of Relativity's pad. Stoke Space has been hard at work constructing a flame trench which is nearing completion. Significant progress has been made with concrete walls and the structural foundations now in place. This is the historic site from which John Glenn's Friendship 7 mission launched back in 1962. It's now being repurposed by Stoke for the launch of its forthcoming Nova vehicle. Stoke has been renovating the site for the past year in preparation to launch its fully reusable rocket either late this year or in early 2026. LC-14 is the pad next door to the LZ-1 and 2 landing pads where we've seen Falcon 9 and Falcon Heavy first stages landing on numerous occasions. Stoke has spent the past month performing more full-duration burns of its Zenith engine and completed testing of its Andromeda thrusters. Zenith burns liquid methane and oxygen in a full-flow staged combustion cycle, and 7 of these will power Nova's first stage in a circular pattern. Flame trenches are a critical component of many launch pads, deflecting the rocket's exhaust and protecting the surrounding infrastructure from the intense heat and acoustic energy produced by the engines. With over 3 meganewtons of thrust when the vehicle launches, we're certainly stoked to see this new flame trench put to the test. I'm sorry, that was terrible. Something that isn't terrible though is our imagery from our latest Space Coast flyover, which you may have seen throughout the Relativity and Stoke stories. You'll be able to see a lot more of this imagery coming this week on our dedicated Space Coast flyover, so click the subscribe button to make sure you don't miss out. Further north at the Cape Canaveral Space Force Station, United Launch Alliance has begun stacking its third Vulcan rocket inside the Vertical Integration Facility. This will be Vulcan's first US national security launch, now that the vehicle has achieved its certification as a result of flying the 2 previous missions. For its forthcoming mission, USSF 106, Vulcan will fly in its 4-solid booster configuration for the first time. Together with its Centaur upper stage, the vehicle will launch 2 situational awareness satellites directly into geosynchronous orbit, the first of many national security space missions planned for the launcher. Once fully stacked, Vulcan will travel roughly half a kilometre by rail to the nearby launch pad at Slick 41. While there's no official launch date at the time of recording, the launch is currently anticipated to take place later this month. But this isn't the first time ULA has begun stacking a Vulcan for this mission. Back in October of last year, the company had already started putting together this Vulcan rocket for the very same mission. However, at the same time, the company was still investigating the cause of the nozzle failure during the CERT-2 mission earlier that month, so that process never saw, for example, the attachment of the solid rocket motors for this specific Vulcan. Eventually, the company destacked the rocket and prepared for other missions, such as the recently launched pair of Kuiper missions with Atlas V. Future Vulcan missions will in fact include its first batch of Kuiper satellites. Other missions in the queue include a number for the US Space Force, the National Reconnaissance Office, and the debut of Sierra Space's Dream Chaser cargo spacecraft, Tenacity. Although, to note, as of Thursday, NASA still has no target date on when that particular launch may occur. Since Vulcan's maiden flight in January of last year, ULA has been working to scale up production and reduce the preparation time between launches. The company aims to launch almost a dozen times this year and has ambitions to launch up to 25 times per year, with many missions already scheduled through 2027. Payload readiness has been a factor for its initial flights, but with this one ready to go, we're looking forward to seeing Vulcan take to the skies once again. Blue Origin has integrated the propellant tanks into the first flight hardware for its Blue Ring spacecraft. The company has been busy manufacturing tanks for its dual propulsion system and will soon have 11 completed for integration into future craft. The Blue Ring spacecraft will offer a number of services, including on-orbit refueling, transporting, and deployment of satellites. This versatile platform is also designed to fully host customer payloads on board, act as a data relay, and even provide in-space computing services. Far from your average space tug, Blue Ring is capable of operating in multiple orbits from medium Earth orbit to cislunar missions. A prototype Pathfinder for the craft was launched on New Glen's maiden flight in January, which demonstrated power systems, communications, and avionics while attached to the second stage. Now, Blue Origin is gearing up for the first proper flight of Blue Ring, which could take place next year on a future flight of New Glenn. Firefly Aerospace has just announced that it's collaborating with Advanced Space to develop services that will support NASA's emerging space network initiative called LunaNet. The 2-year NASA project will develop mission architectures and reference designs for a communications relay, as well as positioning, navigation, and timing, also known as PNT capabilities. Despite what its name might imply, LunaNet is expected to go beyond lunar communication services and could cover Martian and deep space missions 2. It's meant to augment NASA's deep space network, providing local relay and positioning coverage with reduced latency that would support greater autonomy for smaller craft and satellites. If successful, the system could reduce the reliance on ground-based systems and reduce demands on the deep space network by handling high-volume traffic and navigation locally. Advanced Space will utilize Firefly's electro-orbital vehicle as a mobile transfer stage. The project will focus on interoperability, exploring how a relay network can deliver responsive on-orbit mobility and support a communication service across cislunar space. This contract is the second of 2 phases, in which Advanced Space had previously developed mission architectures for small spacecraft using non-traditional orbits. This led to the development of its Cislunar Autonomous Positioning System, or CAPS. In this next phase, the company will draw up some design reference missions to demonstrate that these services can be integrated into a scalable and modular architecture. Meanwhile, Firefly is planning 2 further missions which will use its electro-dark orbital transfer vehicles to deploy Blue Ghost landers. One, announced in March for NASA's Commercial Lunar Payload Services program, will land a Honeybee robotics rover on the moon's near side in 2028 to explore the Groot-Hyson domes for around 14 days. Once in lunar orbit, Electra serves as an orbital relay for those surface assets. With a lifespan of at least 5 years, they could continue to support operations within the LunaNet framework, serving as part of a persistent commercial communications and navigation infrastructure around the moon. From communications around the moon, we now go to Mars, where Rocket Lab has plans for a different orbiting data relay solution. Last week, the US Congress passed the so-called Big Beautiful Bill, and within its language, the bill gave NASA $700 million for a Mars telecommunications orbiter. So, of course, Rocket Lab has not wasted any time and has already made note this week that it already has a plan for a Mars telecommunications orbiter. This plan was part of Rocket Lab's fixed-price Mars sample return proposal. This was submitted last October in response to NASA's call to industry for cheaper solutions that would return samples from the Martian surface, and ideally sooner too. Until Lockheed Martin's proposal, which we covered in last week's show, Rocket Lab's submission was understood to have been the cheapest commercial proposal put forward, and was the only one to include a Mars relay orbiter as part of its architecture. The orbiter would lay the foundations for future missions to the Red Planet, providing persistent, high-bandwidth connectivity between Mars and Earth. It could support existing assets on the surface, such as the Perseverance rover, as well as future sample return missions, tech demonstrations, landers, and eventually human missions. Rocket Lab has already designed and built the Twin Orbiter spacecraft for NASA's Escapade mission to Mars. The pair will study how the solar wind interacts with the planet's magnetosphere, driving atmospheric loss and influencing the flow of charged particles around the planet. This mission is due to launch aboard the second New Glenn vehicle sometime later this year. For now, the orbiter is at the study and proposal stage, but as soon as we hear updates, you can be sure we'll be relaying the news to you. The European Space Agency has just selected 5 launch companies to participate in the agency's European Launcher Challenge. This challenge was proposed at the 2023 Ministerial Council in Seville, with the agency releasing a request for information a few months later in June 2024 and a formal request for proposals in March 2025. The programme aims to increase competitiveness of European launch services, dominated by the more traditional launch company giants Arianespace and Avio. The challenge calls for companies to compete in 2 categories, or so-called components. Component A will be a launch services selection for ESA that should be performed in the period from 2026 to 2030. Component B will be a demonstration of a launch service capacity upgrade, including at least 1 flight demonstration of said upgraded launch capacity planned to be performed by 2028. The program has a 2-phase approach, with the first one having been completed just this week with the pre-selection of 5 companies: ESA Aerospace of Germany, Maya Space of France, Orbex of the United Kingdom, PLD Space of Spain, and Rocket Factory Augsburg of Germany. The agency says it selected the companies based on their technical maturity, business maturity, and sustainability, the institutional market planned to be served, as well as compliance to procurement rules. ESA has allotted a maximum of 169 million euros per challenger to cover the activities under both Component A and Component B of the challenge. If you've been following our channel for a while, you've probably heard of at least a few of these companies before. 3 of them have featured on our Europe's Future in Space series. That's PLD Space, Maya Space, and RFA. NSF has also provided live stream production services to ESA Aerospace. PLD Space is working on its Miura 5 small launch vehicle, which is intended to be reusable using propulsive landing. That vehicle won't initially be able to do that though, and will be upgraded in capacity to allow for propulsive landing. Perhaps that could allow PLD Space to meet the Component B requirement. The company is also working in parallel on its Miura Next family of medium and heavy lift launch vehicles, so that too could be in play as well. French company Maya Space is also working on a reusable small to medium lift launch vehicle called Maya, also featuring propulsive landing. The company has been working since 2022 on developing the rocket and is aiming for a first launch next year. The company, a subsidiary of Ariane Group, is making use of the Prometheus engine already in development to reach the launch pad quickly. During his interview on NSF's Europe's Future in Space series, company CEO Johan Lavoie said that the rocket would have margin for upgraded capacity in the future, reaching up to 4,000 kilograms to certain orbits. In the case of RFA, that company is working on its RFA-1 rocket, which came very close to being the first one to launch out of all 5 competitors. However, the rocket suffered an anomaly during static fire testing last year, which delayed its debut flight. However, RFA is quickly working towards another try later this year, so it may not be too long until we see the RFA-1 rocket back on the pad. British company Orbex is working on its Prime small launch vehicle set to fly in the not too distant future. An interesting feature of this rocket is that instead of having inline tanks, the fuel and oxidizer tanks are coaxial with each other. That is, they're more like a cylinder inside a cylinder rather than one tank stacked on top of the other. Orbex announced late last year that it plans for a larger medium lift launch vehicle called Proxima, so that could probably go towards Component B as well. ESA Aerospace is working on its Spectrum rocket and is the only one of all the 5 companies to actually attempt an orbital flight. Spectrum is also the first rocket to attempt to reach orbit by using propane as its fuel. ESA have been a little bit more quiet about its future plans, so it's going to be interesting to see how the company tries to meet Component B of this challenge. The pre-selection of these 5 companies now allows for the start of Phase 2. In this second phase, the ESA countries that host these companies will negotiate with the companies with a firm timetable and funding that will be proposed at the next Ministerial Council set to take place later this year in Bremen, Germany. This means each host country will need to come up with part of the funding required for the challenge. It also means that in the case of Germany, with 2 companies operating from there, it's going to be interesting how the country decides to fund these companies once all the formal paperwork is complete. Now we'll take a look at some other stories across space, starting in the Pacific Ocean. The US Air Force has paused its plans to build up to 2 landing pads on a small Pacific island, situated over 1,300 kilometers southwest of Hawaii. The Air Force's Rocket Cargo Vanguard program have identified the Johnston Atoll as a test site for a project that would explore the rapid delivery of up to 100 tons of cargo anywhere on Earth. While Starship wasn't named in the proposals, it's implied as the orbital class vehicle in scope. That's clearly Starship. The island is one of a remote chain that has become home to various seabird species, according to objections from the American Bird Conservancy during the environmental assessment stage. The wildlife has been significantly disrupted during the island's time as a weapons storage and test facility until the military vacated the site in 2004. Since then, the island has transitioned into a national wildlife refuge for the likes of terns, albatross, and tropic birds. Concerns were voiced that the last 2 decades of conservation work restoring the bird population could be jeopardized if plans for up to 10 landings per year were allowed to progress. As a result, the Air Force is now re-evaluating the plan and considering alternative locations. Globalstar has signed a second launch services agreement with SpaceX to launch 9 next-generation satellites aboard a Falcon 9 in 2026. The company already booked another batch of 8 of these satellites back in 2023, which SpaceX is due to fly sometime later this year. MDA Space is building the satellites, which use buses from Rocket Lab and will have a 15-year lifespan. The satellites enable Globalstar to maintain and expand its global data and messaging services, including Apple's satellite messaging service. Apple is paying for the majority of the satellite and launch costs and has invested over $1 billion in Globalstar to power its emergency texting feature. As it sought to expand its coverage and eliminate dead spots, Apple found itself in a dispute with SpaceX earlier this year over the valuable spectrum rights. These are the airwaves over which the signals are carried, and they're in limited supply. SpaceX already already operates over 550 Starlink satellites with direct-to-cell connectivity, and argued that the 1.6 and 2.4 GHz bands should be shared and not exclusively used by Globalstar. After some negotiation involving T-Mobile, a deal was reached in which Starlink-enabled texting would work seamlessly on newer iPhones. Despite those earlier tensions making waves of their own, this latest launch agreement clearly shows there's room in orbit for a bit of cooperation. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. This was a rather quiet week for launches, with only a single Starlink launch during the last week. The mission was carrying 28 Starlink V2 mini-satellites into low Earth orbit, bringing the number of Starlink satellites that SpaceX has launched into orbit to 9,165. Despite having just one single launch, in space we had one space station arrival and another space station departure. After launching from Kazakhstan last week, 2 days later, the Progress MS-31 spacecraft docked to the module on the International Space Station. The spacecraft, loaded with 3 tons of fuel, water, hardware and experiments, will now remain docked to the station for about 6 months. After having spent 8 months at the Tiangong Space Station, the Tianzhou 8 cargo spacecraft undocked from the aft docking port of the Tianhe module on July 8th at 0709 UTC. Filled with several tons of waste, the spacecraft was disposed of and deorbited later the same day. That undocking was to open up a port to allow for the Tianzhou 9 cargo spacecraft, which is set to launch next week. That launch is currently looking like it may happen on July 14th at around 2040 Universal Time. Next week we'll also have a couple of Starlink launches from Vandenberg. We're also expecting a pair of customer missions riding on 2 different Falcon 9 launches from Florida. One of the launches is, helpfully, still not confirmed, but it may be carrying the Israeli communications satellite called Dror-1 into geosynchronous transfer orbit. The other customer launch will be for none other than a Starlink competitor, Amazon's Project Kuiper. As always, you can expect NSF to be covering these launches live on our channel and also after the fact in our next space traffic report. In the southern hemisphere, Australian launch company Gilmour Space will try to finally launch its Eris rocket next week. The next launch opportunity will hopefully take place as soon as July 15th at 21:30 UTC. Up next, the Axiom 4 crew is gearing up for its return to Earth. Crew Dragon Grace and its crew of 4 are set to depart the International Space Station as early as July 14th at 11:05 UTC. Splashdown off the coast of California could happen approximately 22 hours after that, depending on orbital mechanics. These dates and times are as ever very fluid, so to stay on top of each and every one of them, don't forget to check out the Next Spaceflight website and app to not miss any of these events. I've been Ryan Caton for NSF, thanks for watching and goodbye.